In this lesson, we will be determining the domain and range of a function, and we're going to apply the knowledge to solve problems. Before we get started, it's important to remind ourselves about a few things. The one thing with domain and range of a function, we need to recall and remember all the way from grade 9, the real number system. So as our friend here on the left has a little bit of an inquiry to say, did you know that numbers that we work with in math belong to a family? They absolutely do. So all the numbers that exist in the world are called real numbers, and they are made up of multiple number sets. So let's remember that, because when we start doing restrictions and domain and range, we need to look at all the possible values that our x values can be. If you recall, that's the domain, and all our possible values for y, which is our range. So the first number set in the real number systems is the natural numbers, and they're often known as the counting numbers, 1, 2, 3, 4. So then the next number set includes the natural numbers, but now we include 0, and that number set is called whole numbers. Added to that would be integers, but whole numbers, integers. So -1, -2, and so on and so on and so on. On top of that, the rational numbers are now numbers that include natural numbers, whole numbers, and integers, but now we're adding numbers that can be expressed as a fraction that include terminating and repeating decimals. The other part of the real number system are irrational numbers. These are numbers that cannot be expressed as a fraction, and their values are not terminating nor repeating. All those numbers create the real number system. So a little bit of a recap. Other terms we want to remember are, what is a function? So a function, remember, a relation is a function if for each value in the domain, there is exactly one value in the range. And that's critical. We learned that doing the vertical line test given a graph, that the graph cannot intersect our line, our vertical line, more than once. Domain of a function. We mentioned it earlier. Domain of a function includes all possible values for x. So the set of all possible values of the independent variable, which are x values. When we looked at, this is also known as the input to our function machine. Range of a function, as we mentioned, is the set of all possible values of the dependent variable, the y values. This is the output in our function machine. Now, we are going to have to set some domain and range, and we want to use proper notation. So we usually express the domain and range using set notation. So as stated there, the general notation. So for domain, like I said, all the possible values for x, we can list them all depending on what information is provided to us, or it is a spread of values. And using proper set notation is very important for this. If you notice, and I put a note to the side, so with the domain there, it says x is an element of real. E, that symbol, is the symbol used to mean element of or belongs to. So when we're stating the domain, we're listing all the possible values. Now, sometimes we can't list them individually, and this is why we say x can be any number. We learned and reminded ourselves that real numbers include all the numbers that exist. However, numbers for our domain are within this spread of numbers. Likewise with the range. Range, again, are possible values for y, and we can state it that as well as set notation. So let's try a few examples. We have determine the domain or range for the given sets. So set A we have given. Domain represents all the possible values for x. So I'm going to just highlight that so we remind ourselves alphabetically x comes first. So I'm going to highlight all my x values in yellow, and then I'm going to take the highlighter just to remind myself again, all my x values, okay, are the first number in the ordered pair, the second, just like the alphabet, x comes before y. So because I'm only given a certain amount of ordered pairs, I'm going to list them, and always list them in increasing order. So in this case, we can say 1, 2, 3, and 4. Okay, range are my possible values for y. And remembering again, although the order that we see in the ordered pairs, they are not in increasing order. When expressing our domain and range, we always want to be conscious of that. So 0, 2, 4, and 6. Set B, again, from lowest to highest. So lowest to greatest, we'll highlight that. Okay, and then we have okay, our possible values for x include 1, 2, 3, and 4. Proper set notation there. And then, of course, when we're determining whether they're increasing or we do have the square root of 3, 2, square root of 5, square root of 6. Well, we know the square root of 4 is 2. This actually ends up being in proper increasing order. So root 3, 2, square root of 5, and square root of 6. These are the only possible values. Moving on to example 2. Now we're given graphs, but if you notice, they're specific points. So when we're determining the domain and range, it's not a spread of values, it's exactly those 4 points in example 2a. So it might be easier to just identify what the ordered pairs are for each of those points to help us out. I'll do that with the first example. So -4 for x, +4 for y, -1, +2 for y. This point here is -2 and 0. And this point here is x is 5, y is -2. Okay, so now it'd be easier to list the domain and range. And again, those specific points are included in this relation. So we have all my possible values for x from left to right. We can say x is -4, -1, -2, and 5. The range, again, lowest to highest. So we start at -2, 0, 2, and 4. Looking at B, we have a whole bunch of scattered points, a little bit tight in there to be able to list them all off, but you would read it from left to right for X and from lowest to highest for Y. Keeping in mind that definition of domain, domain are all possible values for X. So let's start at the far left. Okay, the first quadrant is -4, -3. So we're going to say -4 is included, -3, -2, -1, 0, 1, 2, 3, and 4. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. So we've included them all. Keeping in mind, if there's a repeat, you don't have to list it out twice. So with the range, we have, okay, so we start at -3, -2, -1, 0. There's 2 points with a y value of 0, so we just have to list it once. Likewise, with 1, we have 2 here and here, so we just write it out once, 2, and 3. Well, moving on, now we're given a graph. Now, there's certain points I want to point out when we're looking at these relations. There are arrows on both ends. Now, when you have arrows on both ends, that means that the graph just keeps going and it keeps going. Now, it's impossible to list all possible values. If it keeps going, that means it's not going to stop. So in order to incorporate all the possible values, that's where we say X is an element of real numbers, because real numbers represents all the numbers in the number system. So in this case, if you see, the line just keeps going, keeps going, keeps going, indicating that X is an element of all real numbers. Okay? Instead of listing from -billion to +billion, we just say X is an element of real. Range is the same idea. So we can say Y is an element of real numbers. And just a reminder, real numbers are all the numbers in the number system. So all the possible numbers you can think of are represented in the real number system. Okay, looking at 3b. Here it's a little bit different. If you noticed, we have something called a restriction, meaning the arrows are opening up, but our absolute lowest value happens to be this point here. you're never going to have a value of x that's less than -3. Okay, that's called a restriction, and we have to include that with our domain. So domain, although the arrows keep opening, that sideways V, we know that it can be any possible number, but the number has to be greater than or equal to -3. So we would state x can be any numbers, x is an element such that x has to be greater than or equal to -3. Right? Y, on the other hand, doesn't have a restriction. Y just keeps going, keeps going, keeps going. So for that, we can say Y is an element of real. Okay, this time we're going to look at a couple of relations and we're going to state the domain and range and we're going to define whether it is a function. So let's state the domain and range first, and then from there we can decide whether it's a function based on whether the relation passes the vertical line test. So again, a recap, vertical line test, we would take a vertical line all across our uh, relation from our graph and see, does it intersect the vertical line more than once? If it does, it is not a function. If it intersects it only once, then we know it is a function. So hopefully the A looks familiar. That's a parabola, and we know that's a quadratic function. So that was a concept taught in grade 10. So the very special property about this parabola is that the vertex is that turning point. So in this case, my vertex is -3 and 2. And what that means is, as you can tell from the parabola, it decreases, it gets to the vertex, and then changes direction. Okay, so the parabola is symmetrical about the vertex. So if we drew the axis of symmetry, it would divide that parabola into equal parts. But with that, we know that the parabola, it gets down to the vertex and then changes direction. So this graph, this relation will never have a y value less than -3. It gets to -3 and then changes direction. So with that in mind, the domain, there doesn't seem to be any restrictions on the domain. The parabola keeps going. Remember, the arrows tell us all possible values. We can't list them all. So what we say is x is an element of real. That means it can be any possible number in that exists. So that would entail real numbers. The range, however, it can be any value. So y is an element of real. However, y has to be greater than or equal to -3. And when I say greater than or equal to, that means it includes that point. Okay. Now, doing the vertical line test, let's take out our ruler. Performing that, we can say, if we take the ruler, it only intersects my graph, once throughout the whole graph. So it's safe to say this relation, and therefore this relation defines a function. And we can easily say because I passed the vertical line test. Okay, looking at B, we are familiar with this one. It's a circle. So with a circle, it's enclosed. So what we typically point out, because this is a circle with the center at 0, 0. So if you see, because it's enclosed, we have restrictions. X can be from -5 and to 5 only. It can be any other number in between. However, it is between -5 and 5. So the domain in this case would read, x is an element of real. However, so such that x has to be greater than or equal to -5, but less than or equal to 5. Okay, likewise, if you look, because the circle is enclosed, you have a max and a min for that y value. So we would say y is an element of real. However, y has to be greater than or equal to -5, but less than or equal to 5. Okay, taking out our ruler. If you notice, if we take this ruler and notice it intersects the vertical line more than once. So it fails the vertical line test. So with that, we can say, therefore, this relation does not define a function. Okay, moving on to C. So looking at C, if you notice there's open circles and closed circles. So we have two horizontal lines. One open circle here means open circle, just to refresh, does not include that number. Okay, everything up to that number, but not that number. Likewise, solid circle means the number is included. Okay, so with that in mind, again, domain, all our possible values for x. So you look at your x value. So if we see, I'm just going to take a little bit of a reminder to get down here. Okay, so x, it doesn't include -5, but it includes the fraction rational right up to -5. And then it goes all the way to +2. Now looking at +2, here it is included, and it's not included down below. And this is known as a piecewise function, which we will get into later on. Right now, we just want to state what are my possible values for x. So even though it's not included here, it is included above. So therefore, a value of x does exist at 2, and there's a corresponding y value, in this case at 4. So when we're stating the domain, x can be any number. However, it has to be greater than, not including, so it's greater than -5, but it has to be less than or equal to +6. So notice in our notation, the less than sign does not have an equal underneath because it doesn't include -5. However, at 6, there's a solid circle. That solid circle says it does include. So in that notation, we have to include has to be less than or equal to. So that equal to sign underneath indicates that that number is included. Now, looking at the range, we only have two horizontal lines. So there's only two possible values for R. We can't say y is an element real because we only have two numbers. So we can easily say y is equal to, and list those two numbers, 2 and 4. And hopefully you see that's why sometimes we have to do a range of values, so spread of values. Sometimes it's just two specifics. In this particular piecewise function, which we will get to later on, we only have two possible values for y, 2 and 4. Okay, sometimes we're not given the graph and we have to decide whether a relation is a function and we want to determine the domain and range. So some of these equations are should be familiar to you because one concept, which is in the A, that's a linear function. And that was a big concept in grade 9. So linear function. And then in grade 10, this was the quadratic function. And here we know it's a circle. Okay, so we're given the following equation. State whether the equation defines a function. If it is a function, determine its domain and range. Okay, so by definition, notice that comes back and time again. A function means that for each value of x, there's a unique value for y. Okay? So we know with linear functions, it's a straight line that keeps going and going and going. So we don't even have to graph this. We know. If we wanted to check algebraically, if we sub in one value of x into our function or relation to decide whether it's a function, we would only get one value for y. So let's use a random number. I'm going to say x equals 2. So when x is equal to 2, when I sub it into the equation, I should only have one answer for y. So let's see. Y is equal to 2 times 2 minus 5, always following BEDMAS. So y is equal to 4 minus 5, y is equal to -1. So when x is 2, y is -1. We know because it's a linear function, we know it is a function. So this relation does define a function. It's a linear, specifically linear function. What is the domain? So for any linear function, the domain is always x is an element of real, and the range is y is an element of real. And again, remembering real numbers are all the possible values that exist in the number system. So we can say, therefore, this relation defines a function, more specifically a linear function. Okay. Looking at the quadratic function, we can identify that because it's a degree of 2. So if you recall from last year, that was a big concept in grade 10. But if we wanted to check algebraically, we'd sum, and we're just going to use the number 2 because why not? So x is equal to 2. So we're going to sub in 2 minus 1 all squared plus 3. Always following BEDMAS. So 2 minus 1 we know is 1, all squared plus 3. Y is equal to 1 plus 3. Y is equal to 4. So again, you notice we subbed in a value of x and we only got one answer for y. So in this case, when x was 2 input, my output was 4. So in this case, we do have to remember something special about the quadratic function, just like when we had the graph. The vertex is the key. So in this case, my vertex is 1 and 3. Okay. My a value, which again, we're going to refresh this tomorrow about all the different parent functions, but the a value is positive. So a is equal to positive. That means if I quickly did a sketch at 1 and 1, 2, 3, I know there's my vertex and a is positive, so it's opening upward. Okay. So just a quick little sketch to have an idea of what this function looks like visually. We checked already using algebraic skills that for each one value of x, which was 2, we did have only one value for y. So we already know it's a function, but I wanted to state the domain and range because we don't know what possible values. So having that sketch is a very good visual. So when we sub in and we look at the vertex, we can see that x is always an element of real because it keeps going. The arrows on the problem indicate they keep going. The range, however, we are restricted. So y can be anything. However, y has to be greater than or equal to positive 3. Now, how do we know it's opening upward? If you see at the front, let's see this. Okay, there is a plus there, and that's why I just put a plus. It's not there, but we know. If there was a negative, my parabola would be opening downward, and then the restriction would be a little bit different. Y would have to be less than or equal to 3. Okay. So, so therefore, this relation defines a function. Okay. Looking at C, we have x squared plus y squared equals 64. That is a circle. And if you recall, x squared plus y squared equals r squared. Okay, so algebraically, if we wanted to look at this, we can say, therefore, if we sub in one value for x, we should have a corresponding value for y. Now, if there's only one y value, then we know the relation is a function. If you have two possible answers for y, therefore, this relation would not be a function. And we know the visual of a circle. Circles enclosed, it would fail the vertical line test. Algebraically, I'm just going to use an easier number. I'm going to say let x equal 0. If I subbed it in, it would be 0 squared plus y squared is equal to 64. Well, we know 0 squared is 0, so it becomes y squared is equal to 64. If we take the square root of y can technically be plus or minus 8. So what does that mean? That means when x is 0, I can have a value of negative 8 for y, and when x is 0, y is negative 8. Right there, positive 8. Why would I say it twice? Would be positive 8. Okay, so there you have one input of x being 0 gave us two values for y. Already it would fail the vertical line test. Okay, so therefore this relation is a function, but what is my domain? So with that radius, which is critical, we know domain would be x can be any number, but it has to be greater than negative 8, but less than positive 8. Okay, range, same idea. Y is an element of real. However, it has to be greater than negative 8, but less than positive 8. Okay, but other than that, it can be any value. So therefore, we can say this relation does not define a function. Okay, last but not least, we have determine the range of the function f at x is equal to 4x minus 1 if the domain is, so these are the only possible values, -2, 1, 0, and 3. So by definition, the domain are all our possible values for x. So in order to figure out the range, we would simply sub in these values for x and find the corresponding y values in order for us to define what the range is. So with that, we have the function. So we're going to figure out what is f at -2 by simply subbing into the function given. So which is 4, where we see x, we're going to replace it with -1, and we're going to subtract 1. So f at -2 is going to equal to -8 minus 1. F at -2 is equal to -9. F at 1, we substitute where we see x, we're going to substitute it with 1. So f at 1 is equal to 4 minus 1. F at 1 is equal to 3. F at 0 is equal to 4 times 0 minus 1. F at 0 is equal to 0 minus 1. F at 0 is equal to -1. F at 3, 4 times 3 minus 1. F at 3 is equal to 12 minus 1. F at 3 is equal to 11. So given the domain, we had to calculate and determine what the range would be, meaning what are possible values for y. So we would say the range is equal to, and again, listing it from, right, lowest to highest. So we have -9, -1, 3, and 11.